So here we talk about related to this export and import. You can export any of these features out and then import it from other places, and life gets very, very easy. So what all can you do with it? I have kept, I just have to, I just noted it down here. One of this is in fabrication of sheet metal, it's very, very easy for us, because in principle all fabrication of sheet metal is done in a flat condition. When things are flat, X and Y, handling X and Y is easy. Similarly, when I have the necessary features, when I showed you the small box done out of cardboard and later on done in the sheet metal shop, I started in the cardboard with thickness being 0, there is only nominal thickness, and finally I showed you how my colleague converted into a very convenient small box. Up to that point I could manage, and then afterwards, if you recollect, he has put some buttons and then he has put a display like thing and all that. This is where CAD comes to be of good use. Second thing is, in machine shop you end up with having to work with other hardware, typically how to mount things like connectors, and then do you need to make some spacers, do you need to make bosses, and you need to make D-shaped openings. All these are best handled with CAD. So if you have a what do you call EDM or a wire cut device, any complicated shape can easily be done. Later on in the lecture I will show you samples which you can do. Then we come to very interesting or useful thing is making models. I am sure you too must have been impressed when you saw these architects nice architectural models which they make. Architectural model looks okay, it looks a little like a dollhouse but a little more detail. However, when they show you landscaping and when they show you large buildings in a simple model, they look fine. And I am sure all of movie making shows you two things. There will always be somebody trying to attend a music competition, music and dance, and then our protagonist invariably will be somehow related with architectural models and all that. It seems to be very good as a prop. This apart, they have a limitation at that point. But then using architectural software, fantastic facets, fantastic presentation of everything can easily be done. While the presentation and the other part is very much useful, working backwards, that same thing can be used in providing for all the utilities inside the building. We don't take it seriously, but really the way fire hazards, plumbing, and now recycling and things like how you live comfortable in a house, including ventilation, including where the air circuits and all can easily be done here, and models can be probably be sculpted out of things which are created on the screen. Understood? No, directly from the mind. Earlier from the mind we used to wave hands and show people saying I want it so big and so high and so deep, and then somebody will make it, and then you cut cardboards and all and put it. Now it almost looks like it's something which is useful for people in dealing with occupational therapy. In reality, that is sort of taking a backbench. I have talked to you about standardization and normalization, especially architecture people and then all other plumbing and electrical people. They have their own method of representation of these objects. So very complex 3D things about how pressure is built up in a system, and in the case of hydraulics, things like how whether a water hammer will happen, and in case you have a basement in which there is a water spray is required, how do you ensure that spray comes at full pressure? So I understand at some place there is a diaphragm and something collapses, better walls are open and all that. So model making helps us to make very interesting simple models which will convey more both to the client or the person and the other people who know how to work with these things. Now this other thing has come loosely, we keep on calling about 3D printing, no? It's slightly different. Printing is somehow still related to a two-dimensional object. This generically it is rapid prototyping. One variant of it is the fused filament depositing, which we use, but then otherwise many more complicated things are there. Then you have this laser cutting. So these days online very easily you can get these software which will help you with these things and eventually make things which are possible. So I can't start with a set of rules. All creativity has this problem. If I give you a formula, it's like saying no, how to be a billionaire or a millionaire or something or anything. If somebody has become a billionaire, I don't think he wants to share it that easily with you. One of them is printing a book. So in reality, there are no rules about it. First starting point is somewhere in your mind, you have to think about it, and then after that start doing. First of all is this, you need to play around and keep on practicing what you want to do. So in the screen here itself, you'll notice that some points here, no? Can you see this at the bottom? These lines have been started very conveniently at a specified angle because it seemed convenient, but as the things get populated, you cannot afford to have this. So other way of branching out and all is done. So you must play around a little and then practice a lot and patience. Unless you keep at it, you will not be able to do it. And then in the case of failure, you can avoid it next time. So just like in marketing, 4 P's are there. I believe in this. This is my opinion, I'm sure. When you plan for the next time, you know very well where to start. Then we have this beautiful support groups. Support groups are also used for people in trouble, but then in this case now, we have nice online tutorials, blogs and groups, and then you can go around and at least you can start. And this is not like trying to take something and try to use it and illegally use it. Then is a good starting point. And then finally, if you are serious, there is no option to training. But training will not give you canned answers to all your future problems. Training will give you all the problems, or how to approach things at that point of time. I think I have probably come to the end of this PowerPoint presentation. Now just have a look at a very routine simple thing called a 555 timer. Just randomly hit search and then I ended up with this. So we have at one point here, can you see here? This right side corner picture, we have it's partly layout and partly a component layout and so on, and then partly just underneath this you have the place where you mount all the pads and so on. It's okay. As a starting point, it's a very good way to start with things like this. But you see, remember, all this has to now go into an enclosure, and then that enclosure has to work perfectly. When you talk about a timer, we are not talking about a printed circuit board. What we are talking about is these. There's obviously a big jump, a big chasm which you cannot easily cross just by making a printed circuit board and attaching a cable to it and expect people to wear it. seen this, no? This is about a simple thing. You can easily put it on your thing here. So you see here so many variants of it. It looks a little like the timer we are talking about, except that it has some other hardware attached to it. Then there are pins to this. It does not happen just by accident. This is typically, what is probably a good starting point. You notice there we have a board with holes. One trade name for it is called a Vero board. So attach things on the Vero board and then you put a external power supply. It seems to work most of the time. It works. But then a timer is not just use something in isolation. So you understand here, no? Somebody has made a beauty of a sports timer. So I don't know what all the keys are, but then you notice that there are keys and then there is a display. Display and keys are one thing, and then I am sure some of you have seen this Wish breadboard. So after you finish the schematic, we need to put everything into this Wish board, make interconnections, and then if possible try to make something, transfer it to that other perforated board and stop. At that point, after the circuit is tried and things are easy, you next move on to how to make it work. So it looks easy here, no? You have some voltage and then you have some various things, you are talking about. See this? Already what looked a little like a 2D object, has suddenly ended up into a 3D sort of thing. So this is where I expect CAD timers will help at one extreme level, and then built as a one-off or what you call small things, putting it in a rectangular box and adding some things, saying you have something called start, stop, all this. I do not know actually it is a game or actually it's a timer meant for boxing. This is one of the things I am sure now several of you must have seen it. So we have a beautiful stop clock. So earlier stop clock is not that easy to get. The advantage of this is just what you call buy one and move around, which will come to the next question saying, sir, but I already have it on my mobile. Exactly. Maybe that is the reason why small cameras are out and MP3 players, as we know, are out, and also mobile seems to take care of everything. The good point of it is that you can call anybody. The bad point of it is you lose all your contacts because we have forgotten even the numbers of our callers. What do? Just take it and see their face or recent list or favorite list. You type and then you just select it and you are online. So things like digital diaries and all are still popular, because even if you remove the battery, nothing will happen, you don't lose anything, and it's still possible for you to get the information. So things like this small enclosures and all now will never go out of fashion. There's still a place for one more thing. So we have even interesting things which can be used for other purposes. You have a solid state relay and then outputs are given here and whatever you want. This is the picture of the previous thing which I tried to show you. I didn't know that there will be a demand for it and people would like to buy a timer and use it for watering their garden and so on. Obviously, some point of it is about keeping your grass greener than your neighbors. But the reality is, in more serious things like kitchen gardens and grow your own food and all that, timers which control water flow have become real. So I mean that it's not organized properly. Pardon me with this. I do not know what this millisecond timer is for, what purpose it is. Probably it's for a demonstration, but you'll notice is this whole thing has been built out of a standard enclosure. So there's still place for all of these things. So you have seen already. So we have this again, no? Whether it is I'm not sure whether it's a video game or it is meant for a timing device. We have so many of these things. So we have I thought the last thing, relax and enjoy will be more appropriate. You see here that this is a full-fledged, looks like an IP66 enclosure which is attached to some solenoid or something, and all this is possible with CAD. I'll just take a break from showing you these pictures to actually try to make somewhat general purpose educational kit for teaching embedded systems with one of the professors. So you see here things like the center portion, this one is a printed circuit board. For convenience, I have put 4 holes in the corners. Advantages of being it has been made intentionally stackable. You can stack them one over the other, and this is what when I was talking to you about building a library of components. You see this here. I have spent a lot of time on making this fastener. It's a type of self-tapping screw for plastic manufacturing. Why we had to note this is, as I said, I can scale it up now. Now anytime I want, I can go to a plan view. All the dimensions are accurately represented here. Can you see? I have an 82. I think I need to make it a little closer. You can see nicely I have 82 mm edge of the box, and then one of the edges is 20 mm, and then I have all this dimension. Some of these other things seem to be in a different color. This is intentionally made such that I can go about and I have, if I keep the layers command on selectively, I can switch off the PCB. You have seen here some of these things have gone away here. The PCB has been switched off, or I can switch back the PCB. And I have switched off the top cover, or one of the covers. Similarly, I have switched off one of the other covers. Having done this, you notice that it's now giving me tremendous flexibility in now playing around it. I'll just show it here. This is not the ultimate. See here, I have some construction lines and all built onto this. So just show you or maybe it will make sense only after I push the top cover. So I have a 82 millimeters here. Let's say I am playing around and decide that this thing is not very, what do you call it, it appears a little bigger than what I need. All I need to do is select the whole lot, and this being a somewhat very primitive package, it's not in an editable state, it has been locked and not editable. It's easy for me to adjust all the dimensions. I think separately when I make the exercise, I'll just show you about it. What I just wanted to tell you was that very easy for us to play around with these things. This is a little more complex object which was made for a biological healthcare system. These are what you see in the middle. These are all micro wells in which we carry some samples, and at the bottom we have these very cute guides, and then at the other end you will see here we have a step motor there, then there is a pulley, and then this is attached to this, and then a lot of details. If you want to make say 2 plates into one, it's very easy for me to make it. I can add one more plate, I can cover part of it, and finally, after the whole construction is over, I hope it's not waiting to crash. It's taking longer than required. In this case, I need to now make provision about where I mount the cover, where I mount the electronics, where they go underneath, and then where are all the various guide bushes and all that. I think it's a little slow because of the very complex object. So typically long ago, this is made 25 years back, when we wanted to make a dual mode some device where both Wi-Fi as well as GSM can be connected together. And this is a demonstration piece for the, what do you call, for the technology and how to include them together.